Hey everyone, Mr. Vargas here again for Math 6, and today we are going to be looking at page 391 from your textbook, and this has to do with comparing and ordering rational numbers. So really quickly, comparing and ordering rational numbers. And once again, the root of the word rational is ratio, and we remember that a ratio is just a fraction. So, rational numbers are any number, or a rational number is any number you can write as a fraction. That's basically what the definition of a rational number is. Alright, and here are some examples. 3 over 4. Remember, all integers are rational numbers, since we can just put a little 1 on the bottom, so 2 over 1. So 2 is a rational number. Negative numbers, like negative 4 or negative 3 over 4, those are rational numbers. And most of the decimals that we work with are going to be rational as well, like this. 0.75. That's a rational number. Since I can write that as a fraction, that would be equivalent or equal to the fraction 3 over 4. Okay, so now that we kind of understand a little bit more about rational numbers, let's try to compare them and find out which ones are bigger, which ones are smaller from our homework problems. Okay, number 1. We've got 5 over 4, and we are comparing that to negative 1 over 4. Okay, by this point in time, this one's kind of easy. By this point in time, you guys know that all numbers to the left of 0 are negative. So you have negative 1, negative 2. All numbers to the right of 0 are positive. And you can keep doing that forever and ever. So this one, since we are comparing a positive number to a negative number, our positive number is always going to be bigger. It's always going to be to the right of the negative numbers. So this one we can actually just fill in with the greater than. And that's read 5 over 4 is greater than negative 1 over 4. Okay, let's check out number 2. It's a little bit more challenging. We've got negative 6 1/3 and negative 6.375. Alright, this one isn't as obvious because we need to convert one of them into the other form. It's probably easiest to take 6 1/3, negative 6 1/3, and change that to a decimal. Alright, so let's go ahead and do that. The negative 6 is going to be your whole number, so that goes to the left of the decimal, 6 point something. And now all we have to do is divide the 1/3 to find the rest of this decimal. Let's do that down here. Top dog goes in the house. Bottom dog sleeps outside. Add a decimal 0. Bring your decimal straight up. And that's going to get you 0, 3, mommy multiplied down. And you can keep going. And you'll notice that this one actually repeats forever and ever. You're just going to keep getting 10 over and over. Okay, so that's our favorite little guy with a hat. We've got 3.3, and we can put a repeated. And now we can compare negative 6.333 repeated and negative 6.375 repeated. And this number, since we go to we start from left to right, 3 is the same as this 3, 3 is less than this 7. So since we're comparing a negative number, that means this number is actually bigger. Since this number right here, negative 6.375, would be more to the left on our number line. So we would make our little symbol like that. Okay, let's go ahead and check out number 3. We have negative 3 over 5 compared to negative 0.6. Alright, once again we need to change one of these into the other form. Let's go ahead and take the negative 0.6 and let's change that to a fraction. So we remember place value, this is the ones place, decimal, and this is the tenths place. So what this means is I have negative 0.6 tenths. Okay, so I can rewrite that as a fraction, negative 6 over 10, since this is tenths. Tenths makes a 10 on the bottom. Alright, and we are going to compare that still to negative 3 over 5. Alright, we're almost there. We can actually simplify this negative 6 over 10. Divide the top by 2, divide the bottom by 2, and that will get you a negative 3 over 5. And we'll find out that these two are actually equal. They are the same. Okay, number 4. Negative 9 2/7 compared to negative 9.3. Okay, this is a really hard one. So let's see how we want to approach this. Our best bet is to probably take this negative 9.27 and try to change it into a decimal. So we're going to take this negative 9.27 and change it into a decimal. Our negative 9 is our whole number, so that goes to the left of the decimal. And now all we have to do is divide 2 over 7 to find that decimal that goes to the right. Okay, so let's go ahead and do that. Top dog in the house, bottom dog outside. And we can bring that decimal straight up. This goes, 7 goes into 68 times without going over. Subtract. We can put another 0 on the end and bring that down. And that will give us 5. Another 0 and bring that down. Okay, and that's probably enough for now. You can probably keep going forever and ever. So we're going to stop there. And we're going to put negative 2.857, negative 9.2857. And we want to compare that to negative 9.3. So let me rewrite this. Compared to negative 9.3. Alright, and if we are on the number line, and this is negative 9.3 right here, negative 9.287 would be on this side of negative 9.3. So that means this value, negative 9.287, is actually going to be greater than, since it's more to the right. It's more to the right than negative 9.3. So you're going to put greater than. Okay, let's look at one more example. Number 5. Number 5, order each set of numbers from least to greatest. Okay, here we go. And this is kind of what we were building up to. Alright, so we need to figure out which number is the least and which number is the greatest. Let's use a little bit of process of elimination here. Alright, I've got a positive number, a negative number, a positive number, and a negative number. We know that our positive numbers always are bigger than our negative numbers. So let's put those over here for right now. 2.8 and 3 1/8. Okay, let's take our negative numbers now. Negative 2 3/4 and negative 2.2. And let's put those over here. We're just starting to organize. That way we know we can order these a little bit better. Okay. First, let's compare this 2.8 and 3 1/8. Which is the biggest number out of these two? And of course, the whole number here, 3, is bigger than the whole number here, 2. So in your final answer, 3 1/8 is going to be after 2.8 if we're going from biggest to smallest. Okay, so we've got 2 more spots to fill for our final answer. Alright, now comes down to these two numbers. Which one is bigger, which one is smaller? The best way to do this, once again, is to probably change this guy, negative 2 3/4, into a decimal. So let's go ahead and do that. Negative 2 is your whole number, and that goes to the left. And 3/4 is going to be what we divide to get this part of your decimal to the right. Okay, so let's divide 3/4 really quick. Top dog in the house, bottom dog outside. Bring that decimal straight up. Okay, and this one actually isn't too bad. You guys should be kind of familiar with this, that 3/4 is equal to 0.75, 75 cents, right? 3/4 makes 75 cents. Okay. So now we know that this is the decimal for this. And let's compare that to negative 2.2 repeated. I'm going to draw both of those numbers on the number line. So here we go. We've got negative 2.2 repeated and negative 2.75. How do those compare on the number line? Alright, I'll put 0 here. And it goes negative 1, negative 2, negative 3. Okay. Which number is closer to negative 2? It's probably going to be this guy. Negative 2.2 is probably right there. And negative 2.75, I'll put it in red. That's really close to negative 3. Okay, so which number is smaller? The number that is more to the left, which is this guy right here, negative 2.7. He is going to be the smaller number. So that is the least number in our final answer. So I'm going to put negative 2.75, which is also, negative 2.75 was also negative 2 3/4. Those are equal. So let's put that right here. Negative 2 3/4. That's your smallest number. And then negative 2.2 repeated is your larger number out of those two. Okay, so now we should have all of our negatives on the left, all of our positives on the right, since we are going least to greatest. Okay, that should do it.